Howdy, everyone. Welcome to a visual stroll through Unity's new London office. And so what we're going to be talking about is we're going to be talking about this London office demo that has been built with Unity and a company called Oneros. And we're going to see kind of how the new HD rendering pipeline made these sort of high-end visuals possible within Unity and the sort of workflows needed to make this happen. Now, I just loaded this up here and noticed that this video won't run because the internet is too slow, but this would otherwise be a video that it's going to try to run. But at any rate, this is a video preview of the Oneros applications that we saw originally and thought, hey, this would be a really cool thing to bring into Unity to see how we can visualize some of our offices. Oh, there we go. So the video loaded a little bit. There we go. So this is one of the original Oneros demos, and we saw this and we thought, oh, we need to make one of these. This would be really cool. And so what we did from here is we worked with them to build what we'll load here in just a second, this London office, but we'll actually walk through it and see the project itself, not everything done through PowerPoint, so don't worry about that. We can see, all right, cool, it finally loaded there, and we can see some of the visuals that we're capturing here and exactly how they were done. So, all right, let's move forward here. So the way this project started, what effectively happened is Oneros received the data, the CAD, the blueprint information from the original architect. This is our actual London office, opened like 10 days ago. And they took this and they split into two teams. One team focusing on the environmental pieces, walls, ceilings, structures, pipes, so on, and the other team focusing on all the individual assets, computer desks, monitors, chairs, that sort of thing. Now, the team that started working on the environment, the first thing they did is they built out a very crude, very early version of the FBX layout of the office and brought that into Unity right away so that some of the members could begin iterating on lighting, right? So light baking, light positions, things like that to build this light schema that we need, while the other team started building the high poly stuff in 3D Studio Max. Now the furniture team, they didn't bother bringing anything crude into Unity. They started just immediately in Max building these very, very high poly assets. Now this is an important part of the process. You don't want to start with low poly assets, even though in the end, we don't use the high poly assets inside Unity. Instead, we generate the high poly assets inside like a 3D Studio Max or Maya or whatever, and we generate high poly assets for the furnitures and walls and all these things so that we can bring them into a piece of software called Substance Painter. Now they use Substance Painter, there are a lot of pieces of software that do this, but effectively that takes these high poly models and it breaks out these high fidelity maps. Maps being, textures, albedos, bump maps, normals, emissives, things like that. So what effectively that allows us to do is it allows us to utilize low poly assets and these high fidelity images inside Unity to basically build a very performant but very good looking environment. So back in Unity, you can see they basically take these low poly assets, and I'll actually show you some of these assets and how how the polygons are laid out and what's sort of low poly there. And then using these high poly maps inside Unity's HD rendering pipeline to give us some really impressive graphics there. So let's take a look here real quick about this, or at this here. So here is the actual project. And before I dig in to start, clicking on things and looking at things there, I'm just gonna enter into play mode. And this is going to be a simulation, obviously, of what this will look like when it's a built app. I also have the built app on my machine, but I think it's much more fun to see this running in the editor. And so this actually runs really well. I have a laptop, and this is running at 60 frames a second on a laptop, so very high performance there. And as I look around, we have a lot of really cool, neat things. So again, this is the actual London office. This is exactly what it looks like in real life. And the details are actually really, really impressive. One of the things I always like to show off is this is actually a wall of dominoes, and these are the actual dominoes that they've bothered putting in here. So that's just really high fidelity stuff. And I can walk around in here. There's some functionality built into this. One of my favorites, we have the ability here to just, sort of toggle between some different floors to sort of say, okay, these are some different floors that they were looking at when they built this. So what does that look like? And we can also come over here and say maybe just turn the TV on and off. And this is the actual demo video that we play in the offices. So we can see like sort of the Unity demo reel there with the reflections from the windows behind me. And if we look on here, there's a little bit of product placement. I thought, hell, I'll put my book in there. So look at that really interesting looking book on Unity game development there. I wonder who wrote that. So it matches the furniture so well that I thought it would be a shame not to put it in there. And there's a lot of other stuff we can do. So we also have this rigged up. It's a walkthrough, so we wanted to set up so that we're able to move through doors and everything like that. One of the things I want to point out here that we'll look at again once we're pouring through the project is things like this. And maybe let me get to the side here where we can see it. So if we look at the side of this door inside here, and I don't know if it's being visible on that screen there, but what we effectively have is we have the actual grind marks from where this steel door was ground at the factory. And this is useful, or this is built using a layered material, so that we can use a tileable material with a high fidelity material layered on top of each other to give ourselves a really unique and compelling visual look that's very accurate. Other things we can do is we're dealing with real-time emissives, and what that means is if I come in here and I turn on my lights, we're going to get these real-time emissives, and this is a part of the high-definition rendering pipeline. What effectively this is these objects themselves aren't necessarily lights. They are in fact emissive materials, and emissives emit lights, and we can set these up to actually cascade lights into the office around them, which allows us to achieve some very interesting light shapes and styles. So for instance, if I come over here, I can see another emissive property here, where if I'm looking at these long lights here, these are achievable through area lights and such, but we can also do emissive properties for that. Or if I look here at the PlayStation with the PSVR, those are also emissive properties. Now we wanted to be able to demonstrate some of the actual sort of BIM data used when constructing this office. So if I come over here, this is our BIM room. So if I come in here, we'll actually see some of this information. These are the actual lights that are in that office. So if I feel right now, I could call up that telephone number and be like, hey, we're looking at your lights right now. It's pretty cool. And we can turn them on and whatever. And same with the walls and the floor and all this stuff. Again, this is the actual information, the actual stuff used in the construction of this office. One last thing I want to show in here is these floor reflections. So this is a new feature, part of the HD rendering pipeline, but even new to the HD rendering pipeline. This is something called a planar reflector. So a lot of times when we're dealing with real-time simulation and real-time visualization, we're going to use something called a screen space reflections, SSR. And screen space reflections effectively is basically a shader effect that takes an image that the screen is showing, and it calculates where reflections are going to be, and then it draws those reflections. Right? And that's a great solution. But the problem is if I don't have the source of a light on my screen, right now I can't see those windows, I will not see that window being reflected, because this screen has no concept that exists above there. It is literally a screen space reflection. So I'll have a lot of weird banding on the sides, and if I look down, I'm going to basically lose all my reflections until I'm able to see the light source again, and then they'll just pop into place. And that could be a real problem if we're going for high quality visual, we're going for photorealism. So instead, what we have here is we have a planar reflective surface, and that allows us to establish that this area is basically one giant mirror, more or less, and it's going to be responsible for recording everything that it can see from the ground up, and then overlaying all that information on the floor based on the angle at which we're looking at it and the position at which we're looking at it. And that's a very important thing for achieving high quality graphics. One of the things that's generally very difficult to do in real-time graphics is shaped refraction. And so if I look at this door here, or if I look at this piece of wall, or this piece of glass, we're going to notice that this is glass with these sort of little squares built into it, right? So that's refractive glass, right? So we can see its texture, its bumped, whatever. That in and of itself isn't the challenge. The challenge comes from when I look at this glass at an extreme angle, say like this. Notoriously, what will happen in real time is that's going to cause all sorts of banding. It's not going to be able to calculate light in one side of refractive glass, out the other, but back into the same sheet of glass due to the bumped nature of it. And so that can become real apparent when you, say, walk into an office like this and you have that bumped glass off to your right. You'll notice a bunch of visual artifacts and such. So one of the new things added in HDRP is an improved refractive surface so that we no longer have that issue. Right, so we can see that it's now handling that very well without any of the strange blocking visual graphical artifacts. I really should have taken a screenshot of some of the old things to give it some comparison, but this is actually working very well now. And this is, again, something new that we've put into the HDRP. My favorite feature in this whole office is over here, because they actually put in the actual printer copier that is in that office, and I just think it's fun. It's a Samsung Express, apparently, and I just like that someone took the time to actually do that. So very accurate depiction of the office. Now, when I was talking about low fidelity or low poly models used with high fidelity textures and maps, that's not really easy to tell because the way Unity layers its maps and actually calculates its lighting causes low poly surfaces to actually render as a higher fidelity, right? It's doing all these calculations for you. But you can kind of see it a little bit with the plants. Like if I get really close to the plant, you can see what I mean when I see low poly, right? But generally speaking, if you are standing there in the plant, you're probably a weirdo and probably shouldn't be there anyway. So, you can, sort of break into that to see some of those low poly elements if you want. For the most part, we do a very good job of hiding that. All right, so that's my walk around. So let's actually leave play mode here and let's look at some of these parts. So I'll leave play mode here. Okay. So again, when I'm talking about the planar reflections, I can actually just click on the floor here, and I'm going to look for my reflective plane. I click a few times. Where are you, reflective plane? Sometimes it can be hard to find the pieces I want. Planar reflection. All right. So this is our planar reflection. You can see the plane, and you can actually see the planar reflection preview. This is what this plane sees, and as I move it, obviously, we get that effect. And what that's going to do again is it's going to, you can see the planar probe right there, it's going to be adjusting based on the area that I am, the angle that I'm looking at, so I'm always seeing the appropriate reflection, right? So it's able to pick that out for me. And that's new, and that's a very important part of this sort of photorealistic rendering, right? This also works for things like mirrors, right? In public and whatnot, so people walking through can see reflections there and stuff like that. So that's a very important part. The other thing that really works to make this, an interactive experience, so we saw like when I walked up to something and I'd hit a button and things would turn on, is just Unity's general interactivity. A lot of times people say, well, why bother with Unity, right? I can achieve high graphics in whatever X piece of software, Y piece of software, I can do some of these things with that. Well, we have the capability of doing all of these things with one data set and one platform. So we can do these high quality visuals, but we can also add the interactivity that makes it a dynamic experience. And so if I wanted to, I'm actually just gonna come over here and I'm just gonna do a search for my box colliders. And this is going to show me just all the box colliders used in my scene and what they're used for. So for instance, some of these box colliders are used just to prevent me from walking, say, into a bookshelf, and other of these box colliders are used to like trigger the door opening. So if I look over here, I have this sort of trigger right here. That's going to say, okay, well, I'm approaching the door, and which way am I approaching the door? Should the door swing open? What are we going to do with that? And it handles actually controlling some of these doors. We also have some trigger zones. So if I look at, that's the credenza, let me see here. I'm not interested in the credenzas. Now, I'm looking for the one that triggers my, well, here's another one where we can trigger, again, the doors opening, and one of these controls the actual lights. So yeah, so if I'm touching this collider here, then it's going to give me the option to turn on the lights above the room there. So again, we have that interactivity, which is really cool. One more thing that we can do here. So all of this stuff, all this calculation has happened, all this lighting, everything has been figured out within Unity. All right, and I can see this sort of lighting setup as it exists now. So Unity has this light explorer, and I can click here and I can see, all right, so these are the lights that were used. So we've got a few different spotlights that are used for all these sort of ceiling spotlights and things like that, point lights. We can also see some of our lighting volumes, of the reflection probes we have set up for some of the different glass and mirror elements in the different rooms. We can also see our planar reflection probe there, the different light probes we have set up. So we have a light probe group that's used to handle the real-time lighting for the things that are moving. All right, so that's going to be all calculated so that at runtime we can just sample these probes to then achieve our lighting calculations, and emissive materials, the things that are going to end up glowing for us to give us that sort of cool look. So those are our real-time emissives. Now, one other thing I'm going to show here, so I'm going to go back into play mode, because before I just walked around, just as is with the lighting as is, but as often is the case, we don't want to just see, this lighting as it is. We want to say, okay, well, what will this look like at night? Are these lights adequate enough at night when the sky isn't giving us so much ambient light? And so I'm going to go ahead and just activate night mode. And what that's going to do is it's actually just going to swap out the baked lighting information for a second set that was calculated without any ambient light turned on. So now what we're seeing is we're seeing the lighting just from the office to see if it's adequate enough, right? So sure, it was bright enough during the day with all the light pouring into the windows, but is it still adequately lit at night when we don't have any ambient light provided from the outside? And it seems to be. And again, we can come in here now and we can see that turning on the lights has a greater effect on the overall lighting, because we no longer have that exterior light sort of muting all the light we have inside. And again, I can walk over here, and we walk too slow. I miss my sprint button from video games, so we can turn these on. Now, all of these things, all these lights and everything, these are all standard materials, standard built into Unity shaders and stuff like that. So if I were to just hop over to my scene view right now, while I'm in night mode here, and I were to examine these lights, now what I'm going to see is I'm going to click on this here, and I'm going to see that this is in fact just the HD render pipeline lit shader, right? So this isn't custom, there isn't anything special, this is built-in functionality. We're basically providing an albedo mask, a mask for our ambient occlusion, and a normal map. And then we also are adding some emissives. And so we can do that and look at all of these. These are all just our standard materials. If I was looking at these doors or even this glass, the refractive glass, again, it is all, well, that's the metal part. Give me the glass, there we go. This is again all just that same HD render pipeline lit shader. That lit shader actually handles almost all of our use cases. Again, by just choosing a surface type, what type of blend modes, do we want to have any translucency, do we want to enable subsurface scattering, all this sort of stuff. If you're interested actually in learning more about the HD render pipeline in material properties, crystal versus glass versus metal versus rock, Andy Touch is doing a talk on the HD render pipeline where he's going to show a lot of this subsurface scattering. I pointed at the screen space, that's not what I was talking about, but subsurface scattering and how this stuff is set up. Again, using these ambient occlusion masks in normal maps, and we can see we don't actually have this glass use the refraction transparency just yet. Okay, so again, that's all just this sort of built-in stuff. Now I'm going to go back to play mode here. One of the things that I really like too about this project, so a lot of times, you know, we're looking at this and we're saying, okay, it looks pretty good, but how much of this stuff is faked? What is the deal? Like, you know, what's happening here, right? If I'm looking at this, how much of this is things like post effects that are adding like bloom or distortion or color grading, or how much is just the base assets and things like that? And so one of the things the HD rendering pipeline includes is this debug mode, which it's up to you whether or not you want to leave it in or not, but I asked Oneros, the company that built this, I asked them to leave the debug mode in, so I can just turn this on here. And let's say I'm going to turn off my post-processing to see what the scene looks like without any color grading, bloom, or anything like that, without any post-processing. So we can just turn that off and see that this is what the scene looks like without that. And so things obviously tend to glow a lot less without bloom, and our color grading and our lights are a bit more dull. But now we can actually see what these things look like, what the actual colors and things are without those profiles. Let me just turn that back on there, and we can just sort of get a comparison of the two next to each other. And there's a lot of other things we could turn on and turn off. We could turn off transparencies and pre and post passing, turn off different lighting, screen space ambient occlusion. You can see it's just adding some depth to our shadows there, and so on and so forth. And shadows, well, we don't have any real-time shadows right now. Those are all baked. Transmission here is basically translucency. So we can see that these leaves use a bit of translucency as the light sort of subsurfaces and bounces around the side there to add some illumination. So we can turn those on and off, and we can do all sorts of cool stuff with that debug menu there. All right. So I'm going to leave play mode one more time. And again, things like this ground, with changing the ground. So we saw how if I pressed the key, we were able to change the material on the floor. Let me select the floor there. And so we can see that we have basically some baked light information. And this is also new, where we actually can see what light has been baked and how it was baked. And then again, we can see that it's in fact using, again, still just this lit standard material or standard shader, the HD render pipeline lit. And we can just swap out this texture to get these different color effects. All right, so I do want to leave time for questions, but one more thing I want to show here, which I think is super cool, is, and this one's more just fun. I always notice, apparently in London, there are just a lot of birds flying around. And if anyone wants to see what is actually happening there, you can actually go outside and see these. And this is just another thing, a little behind the scenes stuff. We can actually fly up and actually watch the birds fly around. They're all over here. These are real 3D models flying around in the sky. Again, used to just add some interactivity, some life, some whatever. There's our giant UI there, to this whole world, right? So we look out the window, we see some birds, and you don't think too much about that, but it's just a really easy thing to do. And there's in fact a lot of birds in London apparently, because they're just all over the place. But it's just a fun little sort of look behind the glass there of seeing these birds flying around in the sky. All right. So to wrap up here, again, a lot of times we get asked this question, I can do all this stuff in this piece of software, that piece of software. Why do I need Unity to do any of this? And the fact of the matter is, we're providing a tool set, or we're attempting to provide a tool set that allows you to bring in one data set, one piece of BIM data, geometry, whatever, and use that to build both pre and post sales, to use this to build, just kind of any application you want to use, VR, AR, photorealistic renderings or whatever, and also providing these interactive tools, the ability to basically just do all this real-time rendering and interaction. All right, so like I said, I want to leave time for questions. If anyone wants to try this demo out, you can see me. We also have it at our booths over here. And otherwise, thank you all for listening. Sure. Yeah, so he asked about what's swapping out the material on the floor. There's a script that's, let's see if I can find it, that's mapped basically to the C or the V key, and it's saying, okay, well let's switch that stuff out. Let's see here. I think it's just called floor switcher or something along those lines. I'll try to find it here in a second, but yeah. So basically, it just has a set of, I believe, 4 different materials, and as you hit the key, it's just saying, "Hey, renderer, swap, 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 swap," and so we could just cycle through them by quickly just replacing that. As a matter of fact, let me select the floor, and then we can actually watch what that's doing as I fly around in here. There we go. So if I select the floor, here we go, and so this is that material we're seeing right now. And we can actually just see it's going to parquet. I don't know what that means. Parquet 2, 3, and 4, and then back to 1, 2, 3, and 4. So it's just literally swapping out that material. Any other questions about the project? Cool. Well, thank you all very much.